Trig 3D triangles. Homework, page 250, question 7. So here we're told we have a rectangular box and ABCD is the top of the box and EFGH is the base of the box. So the fact that this is a rectangular box tells us that all angles at each corner is going to be 90 degrees. And we have to always remember that the vertical where it meets the horizontal is also 90 degrees. So we're given some dimensions on the box where we're told AB is 4 centimetres. And obviously AB is also going to be equal to EF, which is also equal to CD, which is also equal to GH. In other words, opposite sides in a rectangle are equal in length. We can also then say that AD must equal EH, which must equal BC, which must equal FG. Again, opposite sides in the rectangle are equal, which means all of those sides are 12 centimetres in length. And then the height of our box, well, we can say that BF must equal AE, which must equal DH, which must equal CG. So all of those are from the horizontal ground vertically up to the top of the box. And we're told that that is 3 centimetres in height. Okay, so the first thing it wants us to do here is to find A to F. So if I look at the box, I can see A to E, which is the height of the box. And I can see F to E, which is running along the ground. And then I need to find this side here, which connects A to F. So because this is a rectangular box, it's like having a cornflakes box on its side. So therefore, if I redraw that triangle, what I'm going to have is A to E. And then that is vertically up. E to F is the base of the box. Therefore, that must be meeting AE at 90 degrees. So they're connecting A to F. It must be the hypotenuse in this right angle triangle. Now, we've already established that AE is 3 centimetres because it's the height of the box. I know that EF is 4 centimetres because that's the width of our box. And therefore AE is opposite the 90 degrees. Therefore that is the hypotenuse in the right angle triangle. So all we need to do here for part 1 is use Pythagoras' theorem. And subbing in our values, well, h squared is the hypotenuse squared, which in other words is AF. And that's equal to the opposite squared and the adjacent squared. And it doesn't matter which one I'm calling opposite and adjacent here, because I'm not trying to find any angles. So if I get the square root, 3 squared is 9, 4 squared is 16. So therefore AF is the square root of 9 plus 16, which is the square root of 25. Therefore the length AF must be 5. And again, units are given in the question, so I must give centimetres in my answer. So part 2 then wants us to find A to G. So if we look at the box, A connects from the top corner of the box to G, which is the bottom corner of the box on the opposite side. And therefore, if I join across there, that's A to G. Well, if I go down vertically from the top of the box to the base of the box, that's going to give me A to E, which we know is 3 centimetres. And of course, then I'm going to have to connect E to G, which goes across the bottom of the box, the base. So again, often we find it difficult to look at the triangle from that perspective. So we take it out and we say, well, A to E is vertically above the bottom of the box. And therefore E to G is going across the base of the box. So when the vertical meets the horizontal, that has to always be 90 degrees. So then by connecting A to G, again we can see we have our right angle triangle. Now I know the height of the box AE is, sorry, that should be AE, not AB. I know that the height of the box from A to E is 3 centimeters in height. I'm trying to find the side AG, which is the hypotenuse, but I don't have EG, so I have to find something else about EG first before I can find AG. Now if I look at EG, EG is on the bottom of the box, and the bottom of the box is of course a rectangle. So that's E, H, G and F. But I know that E to F is 4 centimeters. I know that F to G is 12 centimeters. And therefore if I want E to G, well, that's the diagonal of the rectangle. So I've split that rectangle into 2 right angle triangles. So again, the side opposite 90 is always the hypotenuse. So in other words, I can say that EG squared, the hypotenuse, must be equal to the opposite squared plus the adjacent squared. So in other words, EG is the square root of 4 squared, which is 16, 12 squared, which is 144, and therefore EG must be equal to square root of 160, and the square root of 160 is 4 root 10. Now, if we go back to the question there, you can see that it says give angles correct to 2 decimal places, but it doesn't say anything about the lengths. So I'm going to keep this in surd form because I'm not looking for EG, I'm looking for AG. So if I simplify too early, then that's going to be a problem. So I'm going to put back into my triangle. I know the fact that EG is 4 root 10, and that's centimeters. So now I can see, well, it's just Pythagoras again. So these 3D triangles really is just a repetition of Pythagoras, Pythagoras, Pythagoras for most of the cases, unless we end up with a non-right angle triangle. So let's figure out what AG is. So AG squared is equal to the opposite squared plus the adjacent squared. In other words, AG is equal to the square root of 3 squared, which is 9, and 4 root 10 squared, which is obviously 160. And then AG is the square root of 169. And if I get the square root of 169, I get 13 centimeters. So again, you can see if I had have turned 4 root 10 into a decimal, I probably would have ended up with 12.99 or something like that. So now we have part 2 done. So part 3 is to find the angle AGE. So the angle AGE, well, AGE is in the same triangle that we have just found. So let me call that theta. And I can see in that triangle, I have the opposite now, I have the adjacent, and I've also figured out the hypotenuse. So I can use sine, cos, or tan if I wish, if I put back in that AG is 13 centimeters. So I'm going to go with tan. Tan theta is the opposite over the adjacent. So therefore I can say tan of the angle AGE is the opposite, which is 3, over the adjacent, which is 4 root 10. It says we have to give our answer correct to 2 decimal places for our angles. So AGE is tan inverse of 3 over 4 root 10. So making sure our calculator is in degrees. Then our correct to 2 decimal places is 13.34 degrees. Okay, and then the last part here says find AGF. So if we look at that triangle AGF, Well, we're going from A so we're going from A to F. So that's the diagonal of the rectangle ABFE. And I'm going across to AG. And then I'm connecting F to G. So this is not a right angle triangle, but I do know that FG is 12 centimeters. I have calculated AF. If I go back, AF was the first thing we were asked to do, which is 5 centimeters. And AG we have just calculated, and we found out that it was 13. So I have 3 sides in this non-right angle triangle, and I'm looking for the angle at G because it's AGF, so it's always the middle letter is the angle that I'm looking for. So this is the angle I'm trying to find. So therefore, if I have the side opposite the angle I'm trying to find, and I have 3 sides in my triangle, then it must be the cosine rule. So remembering our cosine rule is page 16 in our maths tables, where if we're looking for our angle, I can take the formula as it is in the tables, which is a squared equals b squared plus c squared minus 2bc cos a. Or I can rearrange that, which is easier when we're trying to find angles, which is going to be cos a is equal to b squared plus c squared minus a squared over 2bc. So whichever you choose to use, if you're using what's in the tables, you'll sub in your values, making sure your calculator is in degrees. Or if you want to take the formula that's in your maths tables and then rearrange it, it makes it a little bit easier, okay? So cos A is going to be equal to b squared plus c squared minus a squared over 2bc. So we need to decide what's A, what's B, what's C. So we're looking for the angle here at G. So that's going to be A in the formula. If I just change that letter there to A. Then the side opposite would be A. Now you can, of course, use the letters G, F, A if you wish. And then it doesn't matter which side is B and which side is C when we're subbing into the formula. It's only ever the side opposite the angle that is the most important one when we're subbing in. Okay, so we have B squared is 13 squared, C squared is 12 squared, minus A squared, that's going to be 5 squared, and that's over 2 multiplied by B multiplied by C. And then to get A on its own, we're going to get cos inverse of that ratio. So let's simplify that ratio. So that gives us 12 over 13. And again, corrected 2 decimal places, this angle is going to be (22°, 0.62). And of course, the angle we were asked for is AGF, so I'm just going to write that as AGF there. Okay, so that was question 7. So question 8. So here we have a Rubik's Cube, and a Rubik's Cube, the keyword there is cube. So cube means that all sides are equal, and we can see that all sides are of 5.75 centimeters in length. So the first thing it wants us to do is look at AC. So AC is on the top of the Rubik's Cube, and it is the diagonal of the square ABCD. So let's draw that. If looking down on the Rubik's Cube, we have A, B, C, and D. And if I connect A to C, that's the diagonal in a square. So therefore, that means that the angle at B is 90 degrees, or the angle at D is 90 degrees, or the angle at A, or the angle at C. So because I'm looking for AC, I'm just going to focus in on one of those triangles. So I'm going to go with ACB. So let me draw that out again. So So 90 degrees, marking the point A, the point B, and the point C. We know that this is a square, so therefore that means that AB is 5.75 centimetres and CB is also 5.75 centimetres. Therefore, if I have a 90-degree triangle, that means the side opposite 90 must be the hypotenuse. So of course, right angle triangle, so Pythagoras. I'm looking for the hypotenuse, so that's AC squared must equal 5.75 squared plus 5.75 squared. And then to get AC, I'm going to get the square root of all of that. It doesn't say how many decimal places or anything like that, so I'm just going to give 2 decimal places because the dimensions were given to me in 2 decimal places, so 5.75. So therefore I'm going to say that AC is 8.13 centimetres in length. So that was part 1. So part 2 wants us to find A to F. Now if we're looking at that Rubik's Cube, where is A in relation to F? Well, A is the top of the Rubik's Cube and F is the bottom opposite side of the Rubik's Cube. So essentially what we're doing is we're cutting through the Rubik's Cube. So let's draw that so we can see what's happening. Okay, so if we redraw our cube so we can see inside it, what we can now see is that if I connect A to F, that I'm going right the way from the top to the bottom opposite corner. And that's the side that I'm trying to get. Now I know that if I go from A down to H, well, that's the vertical height. And if I go across from H to F, well, that's across the bottom base of the Rubik's Cube. So if I take out A to H, that's the vertical height. And if I go across the bottom of the Rubik's Cube, well, that's horizontal meeting vertical, which means 90 degrees, which is F. And then if I connect A to F, that's what I'm trying to find. Well, I know the height A to H is 5.75, but I don't know what HF is. So this is like the previous question, that if I look at the bottom of the Rubik's Cube, it's a square, and it's a square of dimensions 5.75 and 5.75, and that's H, G, F, and E. So by connecting H to F, what I'm drawing is a right angle triangle. So by taking out that right angle triangle, I can then find the diagonal of that right angle triangle using Pythagoras. In other words, that's the hypotenuse there. So again, we can say H squared equals O squared plus A squared. And therefore we have HF squared equals 5.75 squared plus 5.75 squared. So HF is equal to the square root. And if we look, well, it's exactly the same as the previous question. It's just going to be the same dimension, which is 8.13. So really, because it's a cube, I didn't need to do all of this again. If we were clever and spotted at across the top, then A to C, because it's a cube, is going to be exactly the same as H to F. Okay, so we can use the knowledge we already have found from the previous part. Okay, so A to F has to be found, which is our hypotenuse because it's opposite the 90 degrees. And of course, then we have H squared is equal to O squared plus A squared. And again, we have AF squared is equal to 5.75 squared plus 8.13 squared, and therefore AF is the square root which gives us a value of, and again I'm going to go correct 2 decimal places, so that's 9.96 centimetres. So for the last part we want to find AFE, and again if I look, I have just found A to F. We know E to F because that's the side of our cube, and AF. So for part 3, we're looking for the angle AFE, and again, F being the letter in the middle, and we want it to the nearest degree. So really what we should see is that this is exactly the same as question 7, because if I look across at F being the base, then to get the angle AFE, we're looking at this angle here. Well, let's draw that out. I'm connecting A to F. So from top corner to the bottom corner, so this is not right angle, and E to F is going across the base, which we know is 5.75. We've just worked out A to F from the previous question should be 9.96, again centimetres. So really we need to know what is AE in order for us to work out this angle here at F. So again, AE is the diagonal of the side of the Rubik's Cube. But we know that that's 5.75 for A to D. We know that H to E is 5.75, and so is A to H. So therefore A to E if I connect, well, it's just the same triangle again and again and again in this question because it is a cube. So 5.75, 5.75, and we know the hypotenuse again is just going to be 8.13. So I don't need to calculate it again. So therefore, A to E is 8.13 centimetres. I have 3 sides in a triangle. It's not right angle. I'm looking for the side opposite 8.13. So therefore, again, it must be the cosine rule. So again, we have A squared equals B squared plus C squared minus 2BC cos A, page 16. I'm looking for the angle, so I'm going to rearrange that to cos A is equal to B squared plus C squared minus A squared divided by 2BC, or sub in to the given equation as is. And because I'm looking for the angle at F there, then the side opposite is going to be the A squared will be 8.13. And again, it doesn't matter which is B and which is C. So I have 9.96 squared, 5.75 squared, minus 8.13 squared, all over 2 times B times C. And I'm going to get cos inverse of that ratio. And to the nearest degree, if I put that all into my calculator and get cos inverse, I get 54.71 degrees, but to the nearest degree would be 55 degrees. So in other words, the angle AFE to the nearest degree is 55 degrees. So those two questions 7 and 8 were very, very similar. Just one was a cuboid and the other was a cube.